So, and you tell me what you think of this as a physicist, if you would.
Okay.
The idea was that human beings are always trying to calculate a path from one point to another. And the length of the path is going to be proportionate in some sense to the energy used to undertake the task. Okay. Right? The longer the path, the more energy.
What Dr. Jordan Peterson does not understand about physics, and how does it relate to Ben Shapiro, who has a video titled The Atheist Delusion, which is on the topic of Big Bang and the universe.
Once a week, I'll take a commonly made leftist claim, and I'll walk you through all the supporting research to debunk their arguments and expose every fallacy the left throws at you. And what's better? I'll do it in 15 minutes or less. You could spend years researching these topics, you could read all of the books, or you could just come hang out with me here every week and know more on all of these topics than all your leftist friends. Become an expert. Debunked. Only on the Daily Wire.
How does an entire universe full of energy simply appear out of nothing?
Does Ben Shapiro really present the physics of the universe well?
If, for example, the strength of the Big Bang had differed by 1 part in 10 to the 60th power, the universe just would not exist the way that it does right now.
The Big Bang does not have strength. What is wrong here? I will present the latest theory of the universe, accepted by majority of the physics community. The ideas presented here are the state-of-the-art science and are supported by real physics experts. The most successful cosmologists and physicists that have tens of thousands of citations for their published work, such as Stephen Hawking, Alain, Guth, and others. In turn, Ben Shapiro has done no work in cosmology. Stephen Hawking has said that philosophers have not kept up with advances in physics and that art of philosophy is dead. And now I will explain why. The main problem is the use of archaic terminology and lack of understanding of modern science. I proceed to offer an expert opinion on the beginning and evolution of the universe. The purpose is not to destroy moral values held by religious people, as Ben Shapiro might write, but to study and reveal the true origin of the universe. There are religious people who might not like that. A historical example: Stephen Hawking at a Vatican 1981 conference had been told by the Pope John Paul II that science cannot of itself solve the problem concerning the beginning of the universe, and there is needed metaphysical knowledge and not physics, knowledge from God's revelation. What the Pope did not understand is that Stephen Hawking had already come to the conference to present a theory of the beginning of the universe. So how can the universe be created from nothing without God? I will ignore the standard unconvincing answers used by atheists, such as universe had existed before Big Bang, or we just do not know, but that unlike religious people, we do not claim that we do know.
So, okay, so let's walk back 13.824 billion years. Now, in principle, correct me if I've got any of this wrong, all of the matter and energy that constitute the current universe, visible and invisible, is collapsed to, well, to a point that isn't even a pinpoint. It's infinitely small and infinitely dense. And there's a cataclysmic explosion.
Let's start with the basics. Big Bang was not an explosion or a bang. Explosions are caused by chemical reactions, when electromagnetic energy emitted by electrons from atoms cause rapid heating and expansion of gas. An explosion would produce a highly asymmetrical Big Bang that would not look like our universe. The universe does not look like. The real universe looks like. The image is the map of the universe after only 300,000 years had passed since the Big Bang. The entire universe has the same temperature. Then, 75% of the regular matter in the universe was a plasma of protons and electrons, which combined into hydrogen atoms, releasing energy in form of photons. It is the cosmic background radiation. COBE, WMAP, and Planck satellites have measured the cosmic background to greater accuracy. It was the first light that we can observe at a temperature of approximately 3000 Kelvin. Because of expansion of space, the universe increased by a factor of 1000 since then, and the temperature decreased by a factor of 1000 as well. Before we can understand the Big Bang, we have to understand a fundamental result of quantum theory and physics. Empty space, without matter or radiation, the vacuum, as the state with lowest energy, is actually not empty. Because of the Heisenberg uncertainty principle, it is possible for a particle-antiparticle pairs to be created in vacuum from nothing, which immediately destroy and go back to nothing. They are called vacuum fluctuations. Empty space is dynamical and fluctuates. Quantum theory was a monumental discovery that predicted existence of antiparticles that were detected soon after. The vacuum then has energy, and virtual particles modify energy of other real systems, such as causing shift in the electron energy levels of the atoms, which has been measured and confirmed. It also causes the Casimir effect. When uncharged metallic plates are at a small distance, large wavelength quantum fluctuations are excluded, and the effect causes a force between metallic plates that had been measured with success. A vacuum energy, through interaction with gravity, can also cause accelerated expansion of space. The temperature of the universe is the same in every direction, with a small variation on the order of 1 in 100,000, as verified by many experiments, including the Planck space satellite. The variations in the temperature have the exact form as quantum fluctuations in empty space, caused by spontaneous creation of virtual particles. That is how we know the universe was most probably created by a quantum mechanical process, and not God. The microscopic fluctuations were somehow magnified to the size of clusters of galaxies by exponential expansion of space immediately after the universe was created, which caused the effect of the universe being flat and having the same temperature in every direction, which is otherwise impossible to explain, as the opposite sides of the universe after only 300,000 years have never been in causal contact and should not have the same temperature.
If, for example, the strength of the Big Bang had differed by 1 part in 10 to the 60th power, the universe just would not exist the way that it does right now.
Physics can explain why, if strength of the Big Bang differed in 1 part to 10 to the 60th power, the universe would not exist as it is. It is not the strength. The Big Bang does not have strength, but initial curvature, which Ben Shapiro refers to. A universe with no curvature has total energy of the universe equal to critical energy, for which the universe is at a balance between gravitational contraction or expansion. If total energy is larger than critical, the universe will contract and crunch before even a million years. If it is slightly less than critical, it would expand immediately without galaxies and planets forming, and then there will be no life. If the curvature is very small, the universe is flat and at a balance. The total energy of the universe is almost exactly critical, and curvature seems to be fine-tuned to the 1 in part to the 10 to the 55 power, just so the universe can be stable for intelligent life to form 13.7 billion years later. The same argument in a different form.
What are the odds of us being here? Now, the odds of rolling 76s in a row, 1 in 10 to the 55, as it happens, those are the same odds of something called the expansion rate of the universe being just right for the existence of us here today. From the moment of the Big Bang, when our universe began to rapidly expand, the rate of that expansion was exquisitely finely balanced.
Whether it is 55 or 60 is not particularly relevant, partly because we do not know when exactly the Big Bang started. What is important is that the curvature is very small and should be even smaller when the universe began.
Very specific conditions under which our universe was created that allowed for the development of intelligent human life are often used by believers as proof of God's hand. The so-called fine-tuning of the universe for life is extraordinary.
Inflation theory explains why curvature of the universe is so small and why the universe is so fantastically flat without fine-tuning and God. It was invented just before the Vatican 1981 conference by Alain Guth with contributions from others. And Stephen Hawking accepted the idea immediately. It is an exponential expansion of the universe that flattens the space by expansion many times faster than the speed of light. In the process, the universe expanded by a factor of 10 to the 30th power. It was caused by a scalar field that could be the Higgs field, and is very similar to the acceleration of space occurring in the last 5 billion years. That is also perhaps caused by a scalar field, cosmological constant, or vacuum energy. Incidentally, Hawking and other physicists believed in 1980s that the inflation theory could never be tested. But precision technology for cosmology has been advancing to the point that Kobe, WMAP, and Planck satellites have tested the theory to greater precision successfully.
How does an entire universe full of energy simply appear out of nothing?
Where did the energy for the universe came from? The gravitational field is different from other fields. Mass is always positive and attractive, so work is gained by gravitational collapse and bringing mass together. Positive work or energy can be obtained from collapse, and by conservation of energy, the energy of the gravitational field must be negative. Particles with the same electric charge always repel, and work is required to bring the charged particles together. Since work is then negative, the energy of the electromagnetic field must be positive. In a system, the negative energy of the gravitational field cancels positive energy of the electromagnetic field. Then, the energy of the created universe, for all we know, the total energy of the universe, is and could be exactly zero. Further, the fact is that the strength of the gravitational force compared to other forces is approximately equal at the moment of Big Bang. It is an argument by Stephen Hawking and Alain Guth, the most successful cosmologists right now. Do not believe me, believe the real experts. So, the Big Bang can be created with no energy used. All that is required is a small fluctuation in emptiness of space, a small amount of energy that starts the Big Bang. Where could it come from? The answer is quantum theory. Empty space has quantum fluctuations from which energy can be temporarily used, and all that is required to create a universe from nothing can be explained by physics. Fluctuations in the cosmic background radiation are of quantum origin, statistical, and a product of chance. Our galaxy cluster formed at the center of one of high-density fluctuations that became the seed of galaxy formation. In fact, if there were no microscopic statistical fluctuations, the galaxies would most probably not form, and there would be no life.
As it turns out, there are a bevy of logically consistent arguments offered on behalf of God. Take, for example, the first cause proof advanced by Aristotle as refined by Thomas Aquinas. Edward Feser lays out the argument in his book, 5 Proofs of the Existence of God. The argument goes something like this. First, change exists in the world, but all change is the actualization of a potential for that change. So if something is changing, it's because there was a potential for that change in the thing. No potential can be actualized unless something already actual actualizes it. So that means that all change is caused by something already actual. This means either there is an infinite regress of actualizers, or there is a purely actual actualizer. This is sort of like the old joke about the philosopher and the turtle. The philosopher is asked, what supports the earth? And he says, a turtle. And somebody says, well, what supports the turtle? And he says, another turtle. So what about that one? He says, it's turtles all the way down. The infinite regress argument is just not convincing. There has to be something underlying the final turtle. There has to be one prime cause. That cause can't have any potential, because if it had potential, something else could activate it into changing. So there's one unchanging cause that is purely actual. That is the thing that we call God, and it actualizes all of the other changes.
The same argument by Ben Shapiro is a form of many similar arguments that trace back to Aristotle's idea of the prime mover. Everything that exists has a cause, but the cause is also affected by another cause, which is an effect moved by another cause, and so on until infinity. To prevent infinite regress, Aristotle defines the prime mover, the cause of all effects, the prime actualizer, which can be a Judeo-Christian God. It is basically the same idea as presented by Ben Shapiro. The same metaphysical debate ultimately produces no results. The reason is that defined terms are not posed well and are not scientific. Misunderstanding of physics that existed since the classical age was caused by probably the most important philosopher in history, Aristotle, who was considered to be a primary authority on philosophy of nature by everyone, including later the Catholic Church. During the classical age, philosophy and mathematics have advanced considerably, but the old Greeks did not know much about physics because they did not have technology to perform experiments, and scientific method did not exist back then. Peterson understands, for the most part, the same.
Aristotle, for example, when he was writing down his knowledge of the world, it never occurred to him to actually go out in the world and look at it to see if what he assumed about it was true. And it certainly never occurred to Aristotle to get 20 people to go look at the same thing independently, write down exactly how they went about doing it, compare the records, and then extract out what was common.
Aristotle believed that in order for an object to keep moving, a constant force has to be exerted. What he did not understand was friction. For example, a skier moving down the mountain stopped moving because of friction. Another simple example can tell you otherwise. A spaceship in space does not have to use energy to keep moving with constant velocity, because there is no or very little friction, and gravity from other objects is weak. So the old wrong ideas by Aristotle on motion, energy, and force crept into philosophy, including concepts of actuality and potential, and had not changed much since then.
So, and you tell me what you think of this as a physicist, if you would.
Okay.
The idea was that human beings are always trying to calculate a path from one point to another. And the length of the path is going to be proportionate in some sense to the energy used to undertake the task.
That is why Jordan Peterson believes that in order for object to keep moving, energy has to be used, and path traversed is proportional to the amount of energy. Dr. Peterson's misunderstanding is connected with Aristotle's interpretation of energy, potential, and actuality. Ben Shapiro's ideas suffer from the same problems. It precisely explains the reason why Stephen Hawking said that philosophers have not kept up with advances in physics. Scientists have replaced and redefined old concepts by Aristotle with proper ones since 19th century. Metaphysics is not adequate for describing nature, but physics is. The beginning of the universe was a natural, not a metaphysical event. Potential is a well-defined mathematical and a physical function. Every system can have potential energy, usually denoted as V or U. Actuality is not well-defined. There is no such thing as actual energy. It makes no sense. Actuality is a metaphysical concept that has no corresponding physical term that can be discerned from nature. The word potential had been used originally by Aristotle in a sense when something that does not yet exist has the ability to become actual. But in quantum physics, potential exists whenever a vacuum exists. Empty space also has a potential. Everything is actual, and potential is actual as well. Potential also changes its value during motion. So decrease of potential is actual as well. What moves has kinesis or motion, and has kinetic energy, which replaces the nonsense actuality term. So the particles, fields, and the universe can have kinetic energy. In case of the universe, a kinetic energy of expansion. The potential also usually changes, and is also in motion. It shows how concepts of actuality and potential are archaic and useless when studying the beginning of the universe, and have to be replaced by modern physics concepts. The proper definition and replacement of metaphysical concepts introduced in 19th century, is the function potential energy V along with kinetic energy K. Representing motion is the sum of energies, which is total energy of the system, or the difference between energies. A function named Lagrangian L after mathematician Lagrange. A simple useful example is a mountain with a valley at the bottom, where a skier at the top of the mountain has potential to ski down. Initially, skier has no motion and no kinetic energy. After even a small amount of energy transferred to velocity, the skier moves down the mountain, transferring potential energy into kinetic energy of motion. When the skier is close to the end of the slope, the friction starts to be important, and the skier stops in the valley at the minimum.
So, and you tell me what you think of this as a physicist, if you would.
Okay.
The idea was that human beings are always trying to calculate a path from one point to another. And the length of the path is going to be proportionate in some sense to the energy used to undertake the task.
The energy used is not proportionate to the path. It is more complicated. A value of importance is energy multiplied with time, when only kinetic energy is present. The same case as is with the Heisenberg uncertainty principle. More precisely, a sum over time as the sum of all possible configurations of the Lagrangian is performed, and principle of least action provides the proper minimum path. The S is the action of the system, which replaces the inadequate actuality concept by Aristotle. The principle of least action can be used to derive almost every theory of physics. All that is required is a proper Lagrangian function. As an example, for a space without forces, the proper minimum path is a straight line. If there is source of gravity, the path is curved, even for light. The most useful way to think about the Big Bang is that it was not an explosion, but a series of phase transitions at a very large temperature, starting at approximately 1,000,000,000,000,000,000 trillion Kelvin. As a general rule, by lowering temperature, the physics gets more complicated as symmetry is lost. As an example, water vapor is simple. It's only when it freezes that geometrical structures form. Only after the universe expands, structures as galaxies and planets freeze and form. The initial universe was simple, and the gravitational and the Higgs field are the only fields that we know of for certain that had existed at the moment of Big Bang. All other fields were almost certainly a product of phase transitions during expansion of the universe. Energy can be related to temperature, and initially the universe had a lot of potential energy. After a small universe is nucleated by a quantum fluctuation, the potential energy of the universe is at the top of the potential mountain. Then the potential energy is transferred to kinetic expansion of space, and accelerated exponential expansion of space starts. The observable universe size increases by a factor of million, trillion, and just before the fields reach the minimum of potential, exponential expansion of space is over. Then friction occurs, which transfers energy to particles we know, such as Z bosons, quarks, electrons, and photons. And then the standard hot Big Bang occurs. The space and the universe is then flat and homogeneous. Protons and neutrons form from quarks. Helium and hydrogen atoms form, releasing cosmic background radiation. Then the galaxies form, and then the planets as well. That is the simplest picture of the Big Bang accepted by majority of experts in physics community. So it can all be explained by physics. There is no need for religion or metaphysics. Sorry, Pope John. Although all of it does not imply necessarily that Christian God does not exist, but it does imply that universe can exist without God. The Higgs is a scalar field discovered in the Large Hadron Collider in CERN. An example of a scalar field is temperature, which has a certain scalar value in every region of real space. Every quantum field also has its own space, where the potential energy of the field has a value. The electron field is simple, and if there are no electrons, the average value of potential energy is zero. The Higgs field exists in every region of the universe, and its potential energy in the lowest energy state is not zero. It is the Higgs field that provides particles mass, not the Higgs boson, which is a particle 125 times more massive than the proton. Higgs boson is a quantum excitation of the Higgs field, the same way photon as light is an excitation in the electromagnetic field.
We can't look all the way to the Big Bang itself. We can look some fractions of seconds after the Big Bang when the laws of physics spring into existence.
No, Dr. Peterson, you must not confuse the laws of nature with forces, fields, and corresponding particles that adhere to the same laws. In a sense, laws were invented by humans with our language, but also fundamental laws can be considered to exist without humans. Otherwise, the universe would not work. I believe that most of the important laws even work before the Big Bang and for other universes, if they exist. For example, a law of probability should be valid in every universe. What can be said about what happened before the Big Bang is that our theories are incomplete or uncertain, as we cannot directly test them with an experiment. In any case, fields and forces do not disappear as we approach the Big Bang. They are a product of quantum phase transitions. An example, the electroweak force at a certain energy breaks into other fundamental forces, the electromagnetic and the weak nuclear force. It was confirmed experimentally, Nobel Prizes 1979 and 1984. Phenomena of radioactive decay and light are a part of the same electroweak force. The phase transition occurs at a temperature of about a million times greater than the temperature of a nuclear explosion, which also corresponds to potential energy of the Higgs field in the vacuum. It is believed that at the moment of Big Bang, all fundamental forces of nature, including gravity, unite into one force. How exactly that happens is a matter of grand unified theory and theory of everything. Inflation theory explains what happened after the Big Bang, from when the observable universe was approximately the size of an atom. But how does the initial universe form? An experiment that shows how can the universe be nucleated from nothing is boiling water. At a certain temperature, heated water boils because it contains impurities and minerals. A bubble of water vapor can only form and grow around a small impurity that starts expansion of the bubble. But what if the water is pure? Then the phase transition cannot occur and water becomes superheated. Superheated water has an excess of potential energy and has a temperature larger than the required for phase transition. Superheated water tends to evaporate, but it cannot because bubbles cannot form. For a phase transition to be successful, the liquid requires a small impurity or mechanical energy to start a transition from the false superheated state with larger potential energy to a true state as water vapor. The process can be compared to a skier trying to get from a false state of high potential energy to a true state with lower potential energy over a mountain. The skier has to pass from a false valley to a true valley with lower potential energy. The skier or any other classical system like water can only do so by climbing the potential mountain. Transition of the quantum field from a false to a true vacuum can also be compared to superheated water. The formation of a bubble universe is a similar phase transition. The field can pass from false state true to the true vacuum state quantum mechanically, with a certain probability. If the fields were in a superheated state before the Big Bang, the phase transition would create a small bubble universe compared to the size of an atom.
And there's a cataclysmic explosion. That's the Big Bang. That's still part of the standard cosmological model, still an accepted, let's say, fact.
Big Bang seems like an explosion, but it is not. Well, someone might reply, that kind of a phase transition is not real. Such a quantum field with a false and true vacuum does not exist. Not true. The Higgs field is precisely that kind of a field, determined from measurements of masses of Higgs boson and quarks at Large Hadron Collider and Fermilab. It has a true and a false vacuum. Higgs is a quantum field and can decay to the true state by a quantum process allowed by the uncertainty principle. Precise location of the Higgs field is uncertain, and the probability of being in the true state is small, but not zero. Provided the universe lives long enough, say a couple of 100 billion years, the Higgs field and the universe will go through a catastrophic decay eventually. The Higgs field determines the fate of our universe and the vacuum on which all fields and particles live. It is completely different from every other field, which are in turn simple. For example, the lowest value of potential energy of the electron field is zero, neglecting the quantum effects from the Heisenberg uncertainty principle. True for every other field except the Higgs field. The lowest value of the Higgs field is not zero. The Higgs field interacts with every particle and makes them massive, except for the massless particles like the photon. But then also the same particles interact with the Higgs field as well, changing the potential energy of the Higgs field. The most massive particles have the larger effect. The top quark and the Higgs boson have masses precisely so that the Higgs potential has a true and a false vacuum at a very large energy. According to latest data, our universe right now is in a metastable state with approximately 99% probability. The Higgs boson is inexplicably light and should be much more massive, by a factor of trillion times at least, corresponding to the energy at which Big Bang occurred.
How does an entire universe full of energy simply appear out of nothing?
If the Higgs field becomes unstable and the transition to the true vacuum occurs, the whole universe and every particle would be disintegrated, and another universe with new forces, fields and particles would be created, almost the same way our universe was created. Constants of nature would be different, and particles would be more massive, because the vacuum value of the Higgs field would be trillion times larger than it is now. Life would be impossible. The only thing that would survive from our universe would be the Higgs and the gravitational field. Fortunately, lifetime for decay of the universe is much longer than the current age of the universe. Metastability of the Higgs field shows that it is possible to create at least one more universe after a previous one existed, and the next would be unsuitable for life. The decay of our universe and formation of the next universe is a statistical quantum mechanical process. The decay might occur in 1,000, million, or 1 trillion years, but it will occur eventually.
It can't be chance. Now let me ask you, why would we assume that this universe with us in it, which is actually way more improbable than my 70 rolls, is just a result of chance?
While we do not exactly know how our universe began, we do know that the universe caused by decay of the Higgs field will be a product of chance.
Now you could come up with some speculative other theory.
There is nothing speculative about the Higgs field.
very specific conditions under which our universe was created that allowed for the development of intelligent human life are often used by believers as proof of God's hand. The so-called fine-tuning of the universe for life is extraordinary.
If our universe was fine-tuned for life, then why is it in a metastable state, right on the verge of complete destruction? The Higgs boson mass had been adjusted precisely to 1 part in 10 to the 17th power, so that the universe can be in a small metastable region where the entire universe is in a metastable state. If the Higgs boson was even slightly more massive than 125 GeV, the universe would be unconditionally stable. The problem of the Higgs boson mass and the metastability of the universe is one of the most important unsolved problems in physics. Its understanding might lead to discovery of theory of everything. The theory of beginning and evolution of the universe presented here is accepted by majority of physics community, although there are many other alternative theories, too many to be mentioned. However, other theories are less plausible, not supported by data, or not popular, and are based on published work with less citations.